Okay, so let's start. So in the last lecture, we learned about modules section. Okay, what are modules and how do you use the modules? Okay, and like how do you export any values from a module? Okay, let's say if you want to export an array, object, or any string function, how do you export it? That we saw in the last lecture. Today we will start with the concurrency part. Okay, so what is concurrency first of all? So concurrency means like executing multiple tasks simultaneously. Okay, but before understanding concurrency, let's understand how your Node.js code or JavaScript code, basically you can say how it works when you have a only single threaded application. Okay, or a single threaded you only have a main a single thread only. Okay, then how your JavaScript code or Node.js code performs asynchronous operations. Okay, or concurrent operations you can say. Concurrent means parallel operations. Okay, so like every time I used to say there is a event loop which basically runs when you run your code, and whenever there is a synchronous task, it will be taken into another thread, and that will be execute in a separate thread. And once that operation is done, it will come back to your main thread, and then the second event loop will execute. Okay, the event loop will execute till there is no code left to run. Okay, so how does this work in internally? Okay, let's see that. uh, so I'll just create index.js file. Okay, so this is just a simple code with, let's say, console.log hello. Okay, and then there is a set timeout, okay, which will execute after, let's say, 2 seconds, and it will print console.log, okay, um, hello after 2 seconds. Okay. And then we have one more console.log exit. Okay. This is your normal JavaScript code. If you run this, okay, how it will run? So it will be cd concurrency. If I run this code, what will be the output? Can anyone tell me what will be the output of this in a sequence? Yes. Hello. Exit first. Okay. What about hello? Exit hello after 2 seconds. Hello exit. Okay. And what about after 2 seconds? Okay. Exit first, then hello message. Okay. Then 2 seconds. Okay. Yogesh is correct. See, your console.log hello sorry, is not running parallel. It's a synchronous code, right? So this will execute normally. This will print hello. Then there is a set timeout call, which will basically execute this function after 2 seconds. So till that time, we are running console.log exit. So your hello will be printed first, then exit. Then after 2 seconds, you will see, sorry, hello after 2 seconds. Okay. Understood. So that's how it will print. Okay. Hello exit after hello after 2 seconds. Okay, so you'll see node, okay, index.js, and you'll see hello exit after 2 seconds. You'll see hello after 2 seconds. Okay, so that's how your code is executed. So usually what I say is your code, your event loop will execute this. So first, in a first event loop, you have this console.log hello. So it will be printed first. So you can see hello is printed first. Then in the same event loop, we have a set timeout function which will execute 2000 milliseconds. But since it's a set timeout, it will execute in a separate thread. Okay, not in main thread. Okay, So your entire function will be called in a separate after that time interval. Okay, after the time interval is done, then this function will be called and you will come back to your main thread and then this will be printed. Okay, same. So till this function is executed, you have something to execute here in the first event loop. So console.log exit will be printed first. Then first event loop will wait because there are 2 seconds still remaining. So it will wait for your another thread. And that's the reason you can see hello exit. And after that, your console.log hello after 2 seconds is printed. So in the second event loop, this function is executed. This function. Okay. But how this internally works? Okay, in Node.js or JavaScript, how this works. Okay, let's see. So I'll draw a diagram here. So let's say, so whenever your code is executed, okay, there is a event loop which is running behind. Okay, and how this event loop will look like, let's see. So there are basically three things involved in your event loop. Okay, first is your call stack. This is a call stack here. So this is a call stack. The call stack is the stack data structure. So it's basically first in, first, LIFO, last in, first out. So whichever will go into this stack at the last will be executed first. Okay. So that's how your call stack is. And then we have another data structure. Okay. This is called as callback queue. This is a queue. Now queue is basically first in first out FIFO principle. So whichever will come first into the queue will come out first from the queue. Okay, and then we have we can say this as node APIs. Node APIs means the functions or your node environment, you can say. Okay, the APIs which are defined by node, API function, node functions, you can say. Okay, so this set timeout is nothing but a node function. It's a timer function defined by node. Okay, so what happens when I run this code? Okay, let's see. I'll just copy this entire code from this, and then here I will write the say code. Okay. Paste left aligned code. Okay, so this is the code, okay, which will execute. Okay, now let's see what happens when I run this in your Node.js environment. Okay, so how this code will run in your call stack and how it will go to the Node APIs or callback queue, where the code will go. Okay, So first of all, when your code is running, okay, there are basically uh, three code statements that you need to execute. First is console.log hello. Then there is a set timeout function which is called, and then there is a console.log exit. So there are three lines of code that we are running. After that, there is a one more function which will execute. Okay, but that is the afterwards. Okay, so these three lines of code we want to run. Okay, so basically when you run this code, these three lines of code will run. Okay, so first your this line console.log hello. Okay, so when you run your code, this console.log hello will go into this call stack. Okay, so this here it will be console.log hello. Just a minute. So it will be console.log hello. Okay. So in the stack, there is a line console.log hello. So this will go into the call stack. Now, whenever there is a code into the call stack, okay. Now, what Node.js will do is it will take this code, put it into V8 engine. Okay. V8 engine will run this code. And once the output is there, okay. So once your output is taken from the V8 engine, it will be printed on your console. Okay, and then the execution of this code is done. So this will like go away. So this code is taken out of your call stack. Okay, then comes your second code, okay, which is your set timeout. Okay, now what happens when you run a set timeout? So again it will go into the call stack. Okay, so code, it's a bigger code. So I just okay, so let's assume this it's in a call stack. Okay, so when I run this code, it will again go to the call stack. So this block of code will go into the call stack. Now, Node.js knows that set timeout is a Node API. Okay, it's not a V8 engine. Okay, it's not a V8 engine's code. Okay, V8 engine will only run this JavaScript code, but set timeout is a function defined by Node API. Okay, so it will take out this code, this entire timer function, and it will put it into Node API. Okay, and this code will run for 2000 milliseconds, that is 2 seconds. Okay, now at this point of time, it is running in a Node API, or let's say it is running in a separate thread. Okay, but now your call stack, now this call stack is nothing but your main thread. Okay, now this call stack is empty. Okay, as soon as this call stack becomes empty, your Node.js or JavaScript code will execute next line. Okay, this will take this code and it will put it into your call stack. Okay. It will put it into your call stack. Now Node.js sees that there is again a new code that needs to execute in the call stack. It will take this code, send it to V8 engine. V8 engine will execute it. Okay, then whatever the output is, it is printed and its job is done. Then this code is taken out of your call stack. Okay, now here your first event loop is completed and there is nothing to execute now. Okay, after this line. Now, but there is a Node API which is running, okay, for 2 seconds. Now this job is done. Okay, now once this job is done, okay, now what will happen here is I'll just draw one more thing here. Okay. This circle, consider that this is a basically event loop. Okay, this circle is called as event loop. Okay, this is a loop which will basically run whenever there is a thing that needs to execute in a call stack and callback queue. So once your Node API job is done, now what it will do is it will take this code into your callback queue. Okay, so you obviously your set timeout job is done. So this will be okay. Set timeout will go away, but there is a function that needs to be executed. Okay, which is this. Okay, so this is just a minute. So this is the code that needs to execute, but this is sitting in a callback queue. Okay, now callback queue and call stack. Okay, this will basically run whenever there is a call stack is empty. Okay, Now there is no code to be executed, right? So call stack is empty. Now what callback the event loop will do is event loop will run here, and it will take out the first code that needs to execute, okay, from your callback queue. Okay, so first in, first out. So whoever is coming first into the callback will go into the call stack now. Okay, now your Node.js sees that there is a code in your call stack. Okay, this code, it will pass it on to your V8 engine. V8 engine will run this callback function. It will print the console log hello after 2 seconds, and once that is done, your job is done now. Okay, actually when this function is running, okay, there is one more code added on your call stack, that is nothing but this console.log. Okay, actually there is a two lines of code, like two you can say blocks are added in a call stack. First block is your function, second block is your console.log. Okay, which is here, console.log after 2 seconds. So this will execute first. Now its job is done. Now function is completed. This job is also done. Your call stack is empty. Callback queue is also empty. Node API is also empty. So node your event loop sees that there is no code to be executed. Your job is done. Okay, so it will stop. Okay, so that's how your code runs basically. Did you guys get it? Understood how your code runs internally? Okay, great. Okay, this was explained by one of the best means I can see. His name is like Latent Philip, I guess. Okay, he has created one website to see this in an animated way. Okay, I'll just show you that website, Latent Philip. This is the one. So you can visit his YouTube link. Okay, he has explained this scenario in a much better way. I'll just send you this link here. Event loop, he has explained it in very much detail. So copy. Just shared it here. Okay. We can go through that link later on. He has explained this in very detailed manner. Okay, how this callback. You can see that this is a callback queue, a callback call stack, callback queue, and there is web APIs. Now web APIs basically it's running on browser, that's why it is web API. But when it runs on your Node.js, these are called as Node APIs. Okay. Now here also he has written one jQuery code where there is a button. So this is the button. So when you click on this button, there is a function is called, which will basically run a set timeout for 2000 milliseconds, and after 2000 milliseconds it will print you click the button. Okay, and then there is a console.log hi set timeout, which will run after 5 seconds, and there is a console.log welcome to. Okay, so if you run this, okay, there is a I just increase the delay. Okay, so let's see how it runs. Okay, since I have increased the delay, it will run slowly. Okay, so that you can see what is happening here. I'll just run it. See, this code is gone into call stack. Now it's a web API, so it will put into web API. So console.log hi is call stack, it is printed. Then there is set timeout, set web API, timer function will execute. Welcome to log. So this is console.log. The timer is done. It will go into callback queue. Event loop will run. Timeout function is run. Console.log is printed, and then their timeout is done. Okay. So it is quite fast because I guess the delay is not that much uh, useful, but you can see that how it was running. Okay, so this is also web API. Okay, because we are calling a function set timeout. Okay, now this is web API. Now this will run when now you can see that. So this again same. Okay, web API will go in here. Console.log hi is printed. Then set timeout will come. Now this is a timer function will go into web API. Then this will come to loop will print. Then timeout will come, callback queue, event loop will run, timeout function will execute, it will print console.log, okay, and then your timeout is taken out. Okay, now web API is still there. Now if I click on this click me button, you will see that this callback queue is happening. Now on click, there is a timer set timeout function, which will go into web API. It will come to callback queue, your timer function, then console.log, done. This is done. Okay. Okay. So that's how it runs. Understood? So you can go through this link whenever you have a time. Okay. Or just go through his YouTube link. Understood how your event loop works? This is one of the like you can say interview type of questions. Someone may ask you how event loop works, because this is a important part in Node.js. Okay, so you can just explain them how I have explained it to you here. Okay, and you can also go through this his YouTube link. You'll understand it in much better way. Okay, so that's how your event loop works. Understood, everyone, how event loop works? Okay. Okay, cool. Great. Now let's see how you can perform some of the operations, heavy operations, asynchronously. Okay, we'll learn also how to handle exceptions when there are operations which are handled asynchronously or in a separate thread. Okay, if there are exceptions coming into say that asynchronous operation, how we can handle them. Okay, so that also we will see. Okay, so do you want to write it down? You can write it down. This is a simple code. Okay, I'll just move ahead. Okay. So now, what are the heavy operations that we can perform on Node.js? Okay. So Node.js is a backend programming language. Okay. So here we basically create applications which are helpful for creating server and running server-based applications. Okay. Now server will have access to lot of backend resources like your IO, like file, read, write. Okay. Then databases. Okay. Now file handling is one of the major uh, heavy operation, you can say. Okay. So let's see how we can handle the IO operation. Okay. Now for this, your Node.js already provides you the promises, or you can say asynchronous APIs for that purpose. Okay. Like we have a set timeout to execute the task after a certain period of time. We have APIs, IO APIs, which we can execute in a separate thread or in a synchronous way. Okay, but let's see first what will happen if I do this in a synchronous way. Okay, like I'm reading file and printing it in a synchronous way, then what will happen? Okay, let's see that. So I'll just create a new file. Let's call it as main.js. Okay. Now, first of all, how do you read a file? Okay. Now in Node.js, there is a module called as FS module, file system module. So this can be used to read file, write file, and do everything related to files. Okay. So what I will do, I'll just use require FS. Okay. So FS module. From this FS module, you can get read file sync. Okay. Now this read file sync basically will read file in a synchronous way. Okay. Synchronous means the once the first job is not done, your next job cannot be picked up. Okay. So it is synchronous, one after the another. It's not a parallel. Okay. So let's see how we can do this in a synchronous way. So what I will do, I will just create a files array here equals to I'll just add the same index.js file, comma main.js file. So these are the two existing files. So index.js, we already have it in the current directory, and main.js is the current file itself. Okay. Now let's read those files. Now to read those files, it's an array. So I'll just loop through it using for each loop. Here you will get a file. Okay. Now inside, so this is the file path basically. You can see here. To read a file, we'll use const data equals to read file sync. Inside that, you need to pass the file path, which we already have it here. Okay. So this will read a file in a synchronous way. Once the data is read, you can log it out, console.log data. Okay. And then I'll just print console.log here and done. Okay. Now if I run this, what will happen? Let's see. So node main.js, you'll see that it will print in a buffer way. Okay, it's basically when you read a file in a Node.js, it will print buffer bytes array. Okay, if you want to get it in a string, then you have to change it to the in UTF-8 encoding. Then it will print it in a UTF-8 encoded format. Otherwise, it will always be a buffer format. Okay, but that is not we are looking into. We are just looking key how the code is running now. So you can see your first file is read and it is printed here. Okay, if you want to just see which file is read, we can print out the file name here. Let's say file here. Okay. So you'll see first is index.js, then main.js, and then done is printed. Okay, now imagine if this file is a huge file, suppose 100 MB, 200 MB, or let's say 1 GB file. Now, till the first job is not done, your next file will not be read. Okay, because it's a synchronous. And you can see done is also printed at the end. Okay, so still your files are, all files are not read, your done is also not printed. Okay, that means if you want to execute some tasks without which are not dependent on the file read and write, okay, you will not be able to do them. Imagine if you have a server on which you are uploading a file and that file is getting written on your server, okay, on your file system somewhere. Okay, you're uploading that file. Now, if that file is a huge file, let's say 1 GB of file or MBs of files. Okay, now if you write this in a synchronous way, then the other user will not be able to access your server because your server is busy writing that file. Okay, this is a heavy operation and this should be done in a parallel way, on in a synchronous way. Okay, so that your other requests can be served. Okay, how this can be achieved. Okay, also, okay, also before doing this asynchronous way, let's say what will happen if there is a file which is not existing. Okay, so if I do something like this, the asds.js file, this is not existing file. What will happen when I do this? You will see there is some error is printed here. Okay, and you can see index.js file is read, okay, which was correct file, but there is a error on this file because this file is not existing. And you can see enoint no such file or directory, and your code has terminated. Okay, that means you are not able to read the third file, okay, because of the error of second file. Okay, since there is an error on second file, you're not able to read the third file. Also, there is no console log dot done. Okay, so that means if there is an error somewhere in between files, okay, you'll not be able to run the further code, although the next line of code can be executed because the file exists. Also, this console.log should be executed because it is not dependent on this file reading, right? So in that case, how can you prevent this? To prevent this, you can use try catch block, okay, exception handling. So you can just wrap this code this reading of file code in a try block and put a catch block here, error. Okay. Now here we can just write, let's say console.log file not found. Okay. If the file is not found, we can write file not found. And for like, see, when you run the first file, when you read the first file index.js, it exists, so it will print the output here. Okay. Now in the second file's case, you can see the file is reading. Okay, but uh, it got some error because there is no file found. So it will go to the catch block, it will print file not found, but we are not halting. We have caught the error, we are moving ahead. The main.js file will also be read, it will be printed, and then once it is done, your done is also printed. Okay, you can see that here. See, index.js is read, its value is printed, then file not found, then main.js, and then you're done. Okay, that's how you can handle the errors if you have a multiple synchronous calls. Okay, now there might be some different error as well. Okay, different error in the sense, by the way, till this point, did you get whatever, how to read a file synchronously? First write it down, then I'll tell you the next part. Okay, first write this down, write it, execute it, and then let me know once done. So if we have a way to read files asynchronously, do we use this method anywhere? Uh, we have a way to read this asynchronously, but this is used if the if your operation is dependent or your entire code is dependent on your file read. At that time only we will read it asynchronously. Okay. So this method is there for the cases where your code is dependent on your file. Then only we will use this method. Otherwise, asynchronous method is enough. Then, what about others? Yeah, yeah, we'll wait. Okay. Then Jyoti Lakshmi, Divya Bharti. Okay. Okay. Great. Now, so as I told you, like we have only one error here. So that's the reason we are using file not found. Now, there can be another error as well. So just now I told you, if you want to read a file, okay, in a let's say UTF-8 format, the read file sync method has another option, okay, where you can specify the encoding. Okay, so here you can specify encoding as UTF-8. Okay, so it will read the file, the buffer whatever is there, it will read it in a UTF-8 format and it will print it in a normal string. Okay, so if you run this, you'll see that your the file's content is printed here. You can see for the first index.js, this content is printed, and then there is a file not found, okay, because the file is not found. Then there's a main.js content is printed here, and then your console they're done is printed. Okay, now let's say let's imagine that I'm using some encoding which is not existing. UTF-10 is not an existing encoding. And if I run this code, you will see file not found, file not found, file not found for every file, which is not correct, right? This is the file which is existing. But since the encoding is different, we are getting file not found because we are only printing file not found. Then how can we print the exact error which is coming? Okay. So let's go back to our previous case and see what was the error. Like file not found we have printed. Now instead of file not found, I'll just print console.log error. Okay. So what was the error? Let's print it out and see what we can derive from that error, or what value we can get it from the error. Okay, so we can print it accordingly. Just clear this out. You will see a file not found, but this object is printed here. Okay, so this object. Okay. The first file is read, then there is an error, no such file or directory. But this object, you can see it contains error number, syscall, code, and path. So there is one field called as code, which is something different. Okay. So this code basically defines ENOENT means it actually means file not found. Okay, I don't know what that code is given, but the for file not found, the this code is printed ENOENT. Okay, so that means this error object has a code parameter. You can see code. If I print this code, okay, you will see ENOENT is printed. Okay? Now if I check this code, okay, if error.code equals to ENOENT, okay, then we will say file not found. Else we will say, let's say your let's print that code as well. Okay, so or let's say code error itself we will print it out. Okay, so in this case you will see file not found is printed, okay, because file not found. But if you write UTF code which is not existing, and if you run the code, you will see for each and every file, you will see the error, type error, UTF-12 error invalid argument. Now it is not telling you file not found, it is giving the actual error. Okay, but as you can see, the encoding is wrong. And if the encoding is wrong, then it is going to give me error for each and every file. Okay, so in that case, you don't have to go and check for every file. Okay, what you can do is you can just throw this error. Okay, throw this error. When you throw the error, Node.js will take care of that error. You don't have to worry about taking care of the error. Node.js will take care of the error. Okay. Now in this case, if I run it, you will see Now in the first call itself, or in the first file itself, it is giving me the error and it is stopping. Okay, because when you throw the error, it will just stop your code. Okay, because we cannot move ahead. Okay, if the encoding is not correct, there is no point in moving ahead. Okay, but because of throw error, what is happening here is your console.log done is also not printed, because this is synchronous code. This is not asynchronous. Okay. Now we can see that console.log is not printed because it is actually not dependent on your files, right? So this should have been done in a asynchronous way. Okay. We know that if the encoding is not correct, then we should throw an error because no file can be read properly, right? So in that case, it's better to throw an error, okay, and stop the rest of the execution instead of executing it, because it will be wasted, right? If the encoding is not correct. Okay. So instead of that, but this console.log done should have been printed because it was not dependent on this. Okay. For that purpose, we need a synchronous code. Okay. So till now, everyone understood? If you have a this kind of code, how we can handle it? Write it down. Then okay, chalo. Now, how do you handle this asynchronously? Let's see that. So I'll just copy this code. There are two ways you can use it, you can handle this. One is through callback method, and another is using promises. Okay. Now let's see how do you do this with callback first, then promises. So callback.js. I want to run the same code. Okay. But for callback, we don't need this read file sync method. Okay. There's a read file method. Okay. Now we can use this read file method to execute your code in a callback fashion. Okay. I'll just comment this second part. Okay. We will execute it later on. Okay. First execute normally and see what happens. Now for a callback function, what you need to do is I'll just comment this code. Okay. How do you sorry? How do you read this code in a asynchronous way? okay, using callback pattern. Now this read file function, okay, if you see this, it will accept multiple parameters. First is path, okay, which is your file, comma. Second parameter will have options and rest of the code. But there is a third parameter, or you can say second parameters can be callback function as well. There are multiple overridden functions. You can see there's a callback function, okay, which will have two parameters. First is error and second is data. Okay, now the data is nothing but the read data. Whatever the file is read, okay, the data will be here in the second parameter, and you can see asynchronously reads the entire contents of a file. Okay, that means your read file already executes this in a asynchronous way. Okay, this callback pattern. So here we will have a function which will have two parameters. First is your error, comma, second is your data. Okay. Now this type of functions, okay, or this type of callback functions, we call them as error first callback. Okay, in Node.js we call them as error first callback. Error first callback function. Okay. Why do we call this as a error based first callback function? Because if there is an error, then there is a first parameter which will contain error. If there is no error, then this error parameter will contain a null. Okay. Now, asynchronous operations happen on a separate thread. Okay. Now, in that case, as I told you, if there is an error happening, okay, there is an exception, then how do you handle that exception? Because that exception is handling appearing on another thread, right? So how do you get that exception from that another thread to your main thread? Okay, so that is been given to you using this error first callback function. So whenever the callback function is called, so you will come from your another thread to your main thread. Okay, now in when you come to the main thread, it will if the data is there, then it will give you the data. If there is error, then it will give you the error. If there is no error, then this error parameter will be null. Okay, so whenever the callback function is called, so this data will be passed from your another thread to your main thread. Okay, and that's how your error will come to your main thread. Okay, now here again we'll have a data. So we already have a data here, so we can just print that data, console.log file comma data. Okay. And if there is an error, we can handle it through try catch block. Okay, now we don't have to do try catch block here. Okay, because try catch block we can use it when there is an exception coming from a file or function. But here there is no exception. We are already getting error function here, error object here. Okay, let's see what happen. What will so first of all, let's implement this in a, let's say, in a asynchronous way, but for a proper file names. Okay, so I'm just commenting this file. Okay, so there won't be any error now. So if you run this code, okay, let's see what happens, whether this runs in a asynchronous way or not. Let's see. Node callback.js, you will see done is printed first. Okay, in previous cases done was printed later on. Okay, after your all the code is done. You can see that in main.js, when I ran main.js, done was printed at the last. But now done is printed first, meaning your read file function is calling this read file function is basically doing this operation asynchronously in a separate thread. Okay, now once it went into a separate thread, okay, all of this read file function are basically in a separate thread. But this is done, your first event loop is still there and it is executing done. Once this is done, the second event loop, or let's say where in the this diagram, if you say it is there are like two read files are there in your node API. Okay, now when their job is done, the first will come to your callback queue, second will come after that in that callback queue. Now once your code execution is done in a call stack, your callback will queue will take the first entry, which is nothing but your index.js or main.js. You can see main.js is finished first and then index.js is printed. Okay. So whoever completes first will be printed first. Okay. So here there is no, you can see synchronicity. Previously, if you run this code, you see that index.js will always come first and then main.js will come. In this case, whoever completes first will come into the play or will printed first. You can see main.js is the last element, but still main.js is printed first because its job is done first. Okay, so you can see it will be done here. So in the queue, it will main.js is coming first, and then the index.js is coming in the queue. So there are two items in the queue. So your call stack is done. So it will, the event loop will run. It will take the main.js in call stack. The main.js will execute, and you will see the output here. Once that is done, it will be taken out. Then index.js will go into the call stack queue from the callback queue. Your index.js will print the output. Once it is done, it will be taken out. And then there is nothing to implement in the call stack. There is nothing in the queue. There is nothing in the node APIs. Your job is done and it will stop. Okay. But before that, done is already printed. Okay. You can see how it is running asynchronously. Understood how callback function runs your code asynchronously? Okay, sure. So, see when you are running the code, right? So what it does is, see, read a read file. A read file already tells you that asynchronously read the entire contents of file. Then what does read file is doing here? Read file, what it does is, it will take this entire code, okay, into your node APIs. Okay. So first what will happen is, this require function will be taken, it will execute. Then there is an array, okay, which will be there in the memory. But in the for each loop, we are getting one file. Inside that, read file is there. Okay, so read file for index.js will be taken into a separate thread, or you can, or else you can say it will be taken in node APIs. It is executing there. Then will come main.js. Main.js, it is again a read file, so it is asynchronous. It will also go to the node APIs. So now in the node APIs, there are two functions running. One is for index.js and another is for main.js. Okay, and both are basically read file functions. Once this is done, okay, now your call stack is empty. So the next block of code, that is console.log done, will be there in the call stack. It will be printed first. Okay, now it is printed, it will be taken out of your call stack. Now your node API's job is done. That is, first read file is done. Now it can be index.js or main.js, we don't know. Okay, whoever is completed first will be taken into callback queue. Okay, so let's say main.js is completed first, it is taken into callback queue. So it is the first entry. Then index.js will come after that. So it's a queue. So first in, first out. So main.js was there in the first. So it will, event loop will trigger. It will take this code into call stack. So main.js will execute. Once its job is done, then event loop will again trigger it, because there is one more thing remaining in the queue, index.js. It will come to the call stack, it will execute, it will come out of your call stack. Now call stack is empty, callback queue is empty, node API is also empty, and your your node.js code will stop there. Okay, so that's how basically the code runs. Understood, Devabarti? Okay, good. Okay, so write it down, then we'll see if there is error, how we can handle it. You don't have to do try catch block, okay? We'll see that. First do this, then let me know. Don't write this commented code, okay? I'm going to remove it. Just kept it there, or else let's remove it. Okay. Then I get then first after index.js and main.js. That means index.js go first to the callback queue, right? Correct. As I told you, whoever's job is done first will go into the callback queue and it will be executed first. Okay. Every time you will not see index.js first and main.js. Sometimes you will see main.js first, then index.js. It totally depends whoever's job is done first. It will be printed. So in my case, we see main.js here, main.js is printed first, then index.js. Now here, index.js is printed first, then main.js. See, it is random. Okay, it totally depends whoever's job is done first. And whoever goes first into the queue. Okay, and that's what your asynchronous programming is, because it's not dependent. Okay, the reading of file is not dependent on each other, so we can execute them in parallel, asynchronous. Okay, so I think everyone is done, so let's move ahead. Now what if there is an error? So let's introduce this error now and check what happens if I run this code. Okay, now I'm not handling any error, but let's see what happens. You can see there is an error, but you can see done is printed first. Okay, that means your error is not uh, like coming in between your asynchronous code like done. So done is printed first. There is an error on this file. So your undefined is printed because data is not read. Okay, so your undefined is printed, but it is not halting the execution of other files because they are running in a separate thread. So each and every thread is running separately. Okay, and that's the reason you can see even though there is an error here, your other files are reading successfully. Okay, so asynchronous nature will basically do this kind of stuff. Like it will not what you can say, wait for others. Okay, because they are running parallelly. Now here in this case, if you want to handle the error, you can just print this error and you will come to know that this error is nothing but the same error which we got before. Okay, ENOENT wala error. Okay. So this error you will get it. Now in this case, and you can see for others it is null. Okay, so I can see that if error if error is not null, okay, error, and you have to do, if you do error dot code directly, what it will do is for null dot code it will say you cannot access code of null. Okay, so first you have to check whether error is there. If it is there, then check whether the error dot code is ENOENT. Okay, if it is, then print console.log. So console.log your file not found, file not found. Okay, and if there is no error code, then console.log print your code. Okay, else otherwise if you don't keep it else, then the next line will also execute and it will print this code undefined. Okay, we don't want to do that, so you can now see for first it is done, for another is file not found, index.js the value is printed, main.js the value is printed. Okay, so this is how you can handle the code. It is the same that we had done here, but here in this case we are using try catch block. Now in this case we are actually getting the error from your read file only. So we can directly check that error. If the error is null, then the output is there. If the error is not null, then you can print out whatever the error is. Okay. Now, what if you get a error for let's say UTF-12, something like this. So we are using encoding here. Okay. Now, if you do this, you will get C error encoding is invalid encoding. C. Okay. Read file invalid encoding and your execution is halted there. Okay. You can see no further files are read. Okay. Because it's actually an error. Okay. So in this case, your further files are not read, will not be read. Okay. But this is how you can handle the error in a callback asynchronous calls. Okay, this is asynchronous call, but this is callback based. Okay, so in this case, you can handle it the error object. Okay, because this error is appearing in a separate thread, so you cannot do try catch here. Okay, because if you do try catch, there is no error thrown here. Okay, as you can see, when we printed file comma data, the error was not printed. The data was undefined. Okay, so but you can get the error object whenever the callback function will return it, and you can, based on that error object, you can print it out. Okay, understood this? How to handle errors in callback function? Okay, cool. Do this, then we will see promise based asynchronous operation. Then okay, is it done for everyone? Good. Okay, so let's move ahead. So let's see promise based concurrency or promise based asynchronous calls. So let's call it as promise pattern. Promise pattern.js or promise based callback functions. Okay, or promise based. Okay. Now, we have a callback function read file which executes your code asynchronously. Okay. Now we can use the same function here. Okay, const, let's say fs equals to require fs. Okay. Now this fs, okay, fs has a read file method, right? We have a read file method in fs.read file, which is basically an asynchronous function. And this is error first callback function. Okay. Now, why I told you about this error first callback function is because if you have any error first callback function, okay, that error first callback function can directly be converted to promise function, okay, by using one of the library in your or one of the inbuilt module, okay, which is nothing but your util module. Okay, so we can get util. This util module can be used to convert your existing error first callback function only, not all the callback functions. only error first callback functions can be converted to your promises, okay, using this util.promisify method. Okay, here you can pass your fs.read file, that is your error first callback function. This will return me a promise function. You can see it returns you promise. Okay, so that means you can write read file like this. Now this is nothing but your promise. Okay, this is a promise. Okay, because promisify will return you promise, and this read file is nothing but your promise function. Okay, that means if I call read file, the inside that if you pass a path, okay, now I'm not doing it for this, I'll just do it for single file, okay, just to avoid the multiple confusions. Okay, I'll use underscore underscore file name. If you remember, underscore underscore file name gives you the current file path. If you remember, we had done this in a module section. This is the fourth parameter of your function, is underscore underscore file name, okay, which gives us the current file name. Okay, so it's the current file path only. So it will read the promise pattern.js file. Okay, now since it's a promise, you can call .then and .catch. Okay, but I won't recommend using .then and .catch. You always, it's better to write a sync await pattern. Okay, why so? Because as you know, last time also I told you, when you use promises, when you have multiple dependent promises, it will become hell to write such code, such a huge code. Okay, and it will you will not be able to identify the or read the code properly. Okay, in this case also, in a callback case also, if you are doing some callback operation after the operation is done, that means if the read file is done, then you want to do a write file, you have to do it inside this, okay, in a else block. Okay, and after that write file is done, if you want to read one more file, then again after that write file is done, in that callback function you have to do read file. After that read file is done, you want to call, let's say, some network call, okay, or API call, then that's again a synchronous operation. Then this will become, you can say, inside callback there is another callback, there is another callback, there is another callback. This will go on and on and on. Okay, it will be like a callback hell. We call it as a callback hell. Okay, and in that case the code is not readable. Okay, so it always better to use async await pattern. Okay, now how do you write async await pattern? Just create a function. Let's call it as main function. You can name it whatever you want. Okay, uh, prefix it with async keyword, and whenever there is a promise function, write await before it. Okay, this is a promise. This will return me a value directly. Const data equals to this, and we can directly print this data here. Okay, so this will run, and obviously you need to run main function, and you'll write console.log done as well, so that we can see it is running asynchronously or not. Okay, so I'll just clear and run node promise pattern.js. You will see done is printed first. That means this is running asynchronously. Okay, and you will see the output printed here, buffer. Okay, so you can see by converting your error first callback into promise, you can run async await pattern. Okay, use async await pattern. Okay, now sorry, this promisify. Okay, I purposefully told you this function because this is an inbuilt function. But if you have created your own error first callback function, or if you are using some library that has the error first callback function, we can convert that error first callback function into a promise using util.promisify. Okay, but your FS module already has promise function. File promise function is already there. We can directly use const like this, require fs/promises. You can see fs/promises. Okay, you can write this and write a code here. So you will get a read file method. Now this read file is nothing but, you can see it returns promise. Okay, so you can use this read file directly and If you run this code, you will see done printed first, then buffer is printed. Okay. So read file is already there with promise functionality. So you don't need to do this. But this I just purposefully told you, because if you have some error first callback function, that error first callback function can be converted to promise using this util.promisify. Okay. So only error first callback functions can be converted to promise using util.promisify function. Understood how to run promise function? I can see the code is somewhat lesser here. Okay, obviously your now if you want to let's say after reading you want to write into a file, you have a write file also. There is a write file function which is also a promise function. You can see it will return a promise. Now you can run write file after reading a file by, let's say, await. You obviously have to do await write file. Okay, in the write file you have to specify the path name. So I'll just use file name plus, let's say, dot copy. Okay, comma, there is a second parameter which is nothing but your data. So whatever data has been read, you can directly write it into a file. Okay, once done, you can see here. Okay, after reading only the writing will be done. Okay, you can run this code and you will see the promise pattern js.copy is created, and you can see the same code is copied here. Okay, so that's how you can run. You can see that now I can run code like a synchronous way, one after the another. Okay, there is no need to write some callback hell or promises. Okay? That's the power of your async await. Okay, the code will be much readable when you write a async await pattern. Understood, everyone? How to read a file asynchronously using promise or async await pattern? Cool. Okay, write it down. If you want to handle errors here, okay, again you can use try catch block. Okay, this is not an error first callback, it's a uh, promise async await. So last time also we saw, like in async await you can handle exceptions using try catch block. Okay, if there is an error, okay, then you can use try catch block to handle the errors the same way that we had done here. Okay, the same way we can do it here. Okay, if the error dot code envint file not found. Okay, let's see. I do something here which is not found. Okay, now in this case, if there is a exception here, the write file will also be not done, or console.log data is also not printed, because there is an error coming here itself. Okay, so you can see done file not found, and okay, so that's how you can handle error as well, exceptions as well. Once done, let me know. Then wait. Okay, let's see the another way to handle concurrency. Okay, these are the two ways where basically we do asynchronous operations. Okay, and basically callback based and promise based. Async await is a part of promise based. Okay, now there is one more method to handle concurrency when you have a event based things. Okay, now event based is also important part because sometimes there is some event is occurring, and based on that event you want to handle operations. Okay, so let's see how this event based can be handled. Now to handle or create event based concurrency, first of all, you have to create event emitter. Okay, so let's say how you can create event emitter by using, let's say, event emitter equals to, there is a inbuilt package called as events. Okay, now this inbuilt package, okay, can be used to create event emitter object. This event emitter is nothing but a class. You can see it's a class. Event emitter is a class. That means you need to create an object of this event emitter. Okay, so you can create an object using, let's say, my emitter equals to new event emitter. This new event emitter has methods called as emit and on. Okay, so we can use dot event emitter dot emit to emit any event. Okay, so in this case, let's say I specified test underscore event. So this is the event name. Okay, emit. So it's a event name. So this event will be emitted. Okay. Now that event, emitted event, we have to handle that emitted event. Okay. Now how do I handle it? So you can use my emitter dot on method. Okay. In the on method, you need to specify which event I am going to handle. Okay. So I am going to handle test underscore event. This is the first parameter, which is the event name that I'm going to handle. Second parameter is nothing but a listener or callback function. Okay, this is a listener function. We can say callback function. This listener function will execute whenever the event is emitted. Okay? Whenever the event is emitted, this on event will be captured, and this listener function or callback function will be called. Okay, so here I'll say console.log test underscore event is captured. Okay, so let's say I specify test underscore event is captured here. Okay, whenever there is an event is emitted. Now advantage of using event emitter is you can capture it multiple times. Okay, you can capture it one time, you can capture it two times, you can capture it third time. Okay, so let's say I specify one here, two here, and three here. Okay? So if the event is emitted once, it can be captured multiple times. Okay, that's the advantage of using events. Okay, so let's see what happens and how we can emit it. So if I run this code, okay, what will happen according to you? Will I get test event is captured one, test event is captured two, test event is captured three times because I'm emitting the event and then I'm capturing it using on. Shall I get these three console logs? Yes or no? Yes. Okay. That is the understanding we have. Okay. And it should print it like that only. Okay. Because we are emitting the event. But if you run this code, you'll not see anything. Why? Can anyone tell me why it is not showing me anything? If you look at the code, you will understand why I can't see anything.
Sir, we are only emitting, we are not capturing it.
We are capturing it using on method.
Okay.
The on method is used to capture it. Okay.
Okay, sir.
But if you use simple logic here, okay, I'll give you one example. Okay. So let's say most of you have watched the yesterday's football match. Okay. So if that match was live, match is live, okay, and it was started around 8:30 p.m. right? So if you watched it at let's say 9:30 or 10 p.m., let's say 10 p.m. Okay. So you have missed the live broadcast between 8:30 to 10 p.m. right? So there were two goals scored in that period, but you missed those score. Okay, you missed that part. Now after 10 p.m., you started the TV and you are started watching the football match. Now what you will see? You will see the two goals scored between those 1.5 hours, or you will see the next part which is live broadcasted now, which you will see. Forget about the replay and everything, just the live broadcast I'm telling about. So you will see the live broadcast, right? Whichever is coming after 10 p.m. Correct? Now consider here what is happening here. Now tell me what is happening. Can you relate that here? No? See, we are emitting the event first and then we are capturing it. Okay. Code is executed in the background. Basically, before emitting it, okay, okay, before emitting it, your function should be there, which is captured, right? So then only you will be able to capture it. Okay. So here we are emitting first, okay, then we are capturing it. Okay. That means, sorry, you are watching the TV after your goal is scored, right? So your emitting means your goal is scored first, okay, which is between that 1.5 hours, and then you are watching. So you'll not see that those two goals scored, right? So whatever has happened between those 1.5 hours, you'll not see. So whatever is emitted between those that 1.5 hours, you will not see after 10 p.m. So you are what you are doing is you are emitting first, then you are capturing it. That means then you have started watching the TV. Then whatever has happened before, you'll not be able to capture it. Okay. So you can see the emit is the problem here. That means before doing emit, I should subscribe to it, or I should start watching it. Right? Understood everyone? What is the problem here? So what change I have to do here? What change I need to do here?
Using that my method on first and then
Okay.
emitting it.
Yeah, pardon, I couldn't hear you properly. Hello?
Sir, using that dot on method first and then
Yes,
emitting it.
correct. You have to emit it afterwards, after you are subscribed to or after you have started watching the TV. So after you have subscribed to the event, then only you can emit it, and once you emit it, then you can obviously see what is happening in the event, right? Emit is occurred after capturing, correct? So here in this case, we have to emit after the we start watching on it, or after we start capturing the events, right? So here now if you run the code, you will see the test event is capture 1, 2, 3. Now capture means like you are watching like on three different TVs. Okay. So you will see the same output on three different TVs. Okay. Understood? Understood, everyone? Those three can be three different TVs, or one can be mobile, one can be laptop, one can be TV. So there's three can be different devices. So here also we can use the same event to do different tasks on different positions. Okay, the same event can be captured for to doing multiple tasks. This is what is event based mechanism is. Okay, this is just a introduction for you for event based handling. Later on, when you do some huge large level projects, that event based mechanism will be very much helpful for you if you understand this now. Okay, understood, everyone? Like if you see Kafka and all, every Kafka queuing mechanism, this all basically works on event-based mechanisms. And this event-based mechanism is very much helpful for performance-based applications and parallel execution of the applications. So if you understood this, but there is a tricky question here, or you can say interviewer might ask you the question like this: what if I don't want to do this, I want to emit before? Okay, I want to emit it here only, and then I want to capture it. Then can you tell me what can I do here so that my emit will happen afterwards? Okay, although I'm writing the code before, but the emit will happen after the watching on those events. Anyone can tell me what should I do here so that
Sir,
this
can
emit
we
will
use set timer?
correct? We can use set timeout. Set timeout will what it will do? It will delay my execution after that time period. Okay, till that delay is there, you're already subscribing to all the events, right? So you can use set timeout here. Okay, and you can just put even 1 millisecond also, that will also do, or you can do 0 milliseconds as well, because when you do set timeout, it will go into another thread, and it is an another thread. So your first event loop is already doing everything here. Okay, and once this event loop is done, your second the timeout will come or take your code from your another thread to main thread, and then it will execute this event. Okay, and then you will see the same output. Okay, now this set timeout has a set timeout with 0 milliseconds has alternative. You can use set immediate as well. Set immediate is same or equivalent of doing set timeout 0 milliseconds. Okay, so you can see this set images like doing the same thing after first event. Okay, immediately after first event loop is completed, your set this function will execute. Understood this? Okay, so do it. And one more thing, even if you define an event here, okay, if you want to capture it on another file, okay, that is also possible. Okay, so let's say I have another file, use event based .js. Okay, so I'm just using it const, let's say event based equals to require, and then I will use event dot slash event based here. Okay, and then I want to capture this event. Okay, now for this I need this event emitter. So what I will do, I will use module dot exports to send this event emitter here. so that I can emit use here. So let's call it as my emitter only. Okay, we can name it as whatever you want. After this, you can use my emitter dot on. Okay, so I want to capture it another file. Okay, the same test event. So here, let's say I call console.log and test underscore event is captured 4. So here I'm doing test event captured. Now your event is emitted from this file, but still you are in another file. So it will be captured here as well. Okay, because it is immediately executing after the first event loop. So you can execute your use event based.js and you will see test event captured 4 as well. Okay, so that means your some other file or library is doing emitting a job and you are capturing it in your own file. Okay, understood this? Means you can use it in a separate file as well. And one more thing, okay, that is, if you want to emit an event with some parameters, you can do that as well. Okay, let's say I want to say hello guys, something like this. Okay, and you can send any data, just a string, number, object, array, whatever you want to send, you can just send it. Okay, and whenever you send that data, you can just capture the data here. Okay, in everywhere you can capture the data everywhere. Okay, you can just say here data. Okay, or yeah, that's it. You can see data here. Even in this case also you can see the data, comma data. Okay, so the what it will do, all of them will get the same output which is emitted by your emitter. Okay, so if you run this, you will see everyone will get hello guys, hello guys, hello guys. Okay, that means if you want to emit a data, whenever you are emitting an event, you can just send it after the first parameter. You can write comma separated values, multiple parameters, or you can just send all the data in a single parameter in an object or array. Okay, that is also possible. Understood everyone? Okay, do it. Once done, let me know. Then okay, so that's it on modules and concurrency. So we have covered everything in regards to modules and concurrency. So the next topic that we are going to start is Express. Okay, but we will not start it today. We'll start it in the next lecture. Okay, the next lecture will be on Wednesday. Okay, tomorrow there is no lecture, so it will be on Wednesday. So we'll start with Express and start building some web application using Express. Okay. So till now, whatever you have done in Node.js will be helpful for you whenever you develop any application. Okay, and Node.js is not just only for web application; it can be used for server side heavy rendering. Okay, and performance based applications as well. Okay. So remember whatever we have done in modules, concurrency, asynchronous operations. Okay. It will be helpful for you in future. Okay, any questions, any doubts in today's lecture? Is it clear, everyone? Okay. Okay, good. Then we'll stop here. Meet in the next lecture on Wednesday. So when to use async await in what type of code? Mostly async await will be used whenever there is a promise function. If there is a promise function, then only you will use async await, and most of the time you will use async await. Okay, we'll see that in when we do Express application using some MongoDB integration and all. Okay, because those will be database calls and those will be asynchronous calls. So at that time we will use async await. Most of the time you will use async await whenever there is a promise based function. Okay, chalo then, bye, good night, take care.
Hello, sir. Error.
Yes, Sophia. Rest all can drop. I'll just stop the recording here.